applications. And the sense of that they are actually dynamic web applications, we are going to define the main actors behind delivering a web app in a dynamic aspect. First unit is talking about the ASP.NET, and we said that this is a Microsoft product. It is a technology that we can use to generate the front end solutions. The sense of the front end is that they are web pages, websites. Let's say the interfaces where the users receive responses or services, or the users themselves, they can pass requests and comments. So the technology, the ASP.NET active server page, and based on the .NET framework, which is from Microsoft. Also, we are going to define what is the .NET. Actually, it's a platform where we can find already predefined functions and tools that we can utilize as per the needs. So let's pass to the first definition, which is actually talking about what is, let's say, the context of the web solutions or web applications. A web application, it is actually a front end and then interaction in between a front end and a service provider, front end application or interface and a service provider, where the user can actually reach his requirements. In the sense of, if you are willing to, for example, read the news of today from the Omani, let's say, Al Watan journal, you can go to the web URL where the Al Watan is hosted, and you can read the data. So you are using a front end interface. A web application is a web service actually provider. It is a sort of a front end. It is an interface. It is a solution that the user can reach his needs, but using a tool which is a browser in our cases here. Uh, it is not the unique solution. It's not the unique tool, but it is very famously known. The browser is utilized to reach the services. Briefly, this is what can be given as a definition to what is a web-based application. As per an example, we can take the example of the Google Docs. Can we write a document online? Can you write a Word report? Yes, we can. Actually, the example of the slides you are seeing now, I'm explaining to you and I'm presenting you slides here. You see the PPT I'm presenting you, this chapter number 1. I'm sharing with you, if you are able to see this interface. This is an example of a slide presentation, but using an online service. It is from the Google only. It is from the Google only. If you see the URL, actually, it is from the Google, and this service helps me as an inspector to present you my data, and helps you as students to visualize and see the results, or let's say the output, or what I'm displaying to you. So this is an example of a Google Doc. Actually, sorry, it's a Google product. It's not doc, because this is a PowerPoint. It's not a Word, and I'm able to provide you what I'm presenting without needing to install any prerequisite in my computer. No, it's not in my computer, but actually I'm using a web solution. I'm not installing any software or any, let's say, application in local in my computer. No, I'm only using the online, what Google is providing me, which is the presentation, the PowerPoint, actually, the presentation solution provided by the Google. So this means that I'm using actually a web application, a web-based application. Is an example of a web application. Web application means that you are going to utilize, you are able to utilize it anywhere, anytime, in the sense of that you are able to reach the resources using any device at any time during the day or during the week, or anytime and anywhere, wherever you are, at home, here in university campus, in Oman, UAE, in United States, in Tunisia, wherever you are able to reach this or those services. And also, in any time means any time of the day, or any time of the week, or any time of the month, or any time of the year, any time. Those are features from the being utilized in a web-based application. Then also, since we said that anywhere and anytime, is it able to? Are you required to carry on your desk computer with you to reach those services? No, 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 no. We do not need a uh, specific actually tool to visualize or to reach those web applications. We may utilize actually our ready-made, already equipped devices. We say the mobile devices, smart devices, with their equipped browsers to immediately reach the web applications. We do not need to install a specific software on a specific hardware to reach the web application or web resource. No, no. Immediately you just access the URL remotely using the browser simply. Good. Uh, they are not actually specific to a specific hardware or specific software. They are actually given to you to be accessed using any device, any hardware, any software. Means in the sense actually I'm saying here any software in the sense of that it has to give you the chance to access the web. That's it, the www environment. So because the browser or web browser, it's not the unique tool we can use to reach the web, the www environment, to access the internet, for example. It's not the unique, but if any tool you have and is able to give you the access to the internet, so it is equipped and it can give you actually the chance to reach the web solution, web application. And other features, since we said that, for example, the example we took here is the Google Docs or the Google Slides here as shown. Now, there are solutions, they are not free. There are services or applications or solutions, they are not free, means you have to pay for the use. Here we are going to define later on the context of cloud computing. And actually, for the example, let's say the example of the Microsoft Word, MS Word. If you want to utilize the MS Word on your computer, you have to buy the license certificate and to be genuinely actually utilizing this software on your local computer. You have to pay the license once for all to be yours. Otherwise, you are not allowed to utilize, and you cannot use it. So to install the Word on your computer, you have to pay for the license. And either you use it or you don't use it. It is like that. You cannot install it unless you pay for the license. When you compare this behavior to the web-based solution, no, it's not like that. For the web-based solutions, we don't pay for a license, but we pay for what we need. If you want to use an application or a resource online, you pay for the use only. What you use, you pay for it only. You use it for 1 hour, you pay for 1 hour. You use it for 1 day, you pay for 1 day. You use it for one computer only, you pay for one computer only, and so on. Pay as you go. Means whenever you need, if they are paid resources, you pay for the use based on your need only. In addition to the web applications, actually they are scalable. Means in the sense of since they are web applications, so we can reach them through the web, through the www environment. Means how many users we can use? We can use actually as many as the application can be utilized by as many as users as they are actually requiring the service, this same service. Thus, they have to be scalable, and they are scalable actually. Means those solutions, they are scalable in the sense of you can or they can accept more users as per their need at the same time. At the same time, yeah, and very famously, that mobile devices and smart devices of today, they are actually capable of accessing web solutions. Means if you can take the example of for example, those slides here, or the Google Docs, or the EduWave in our campus here in our university here. The use of smart devices can lead us also to reach those services. Yes, absolutely yes. So this is one of the features. So that you have to consider. Actors actors. They are responsible for genuinely and clearly drawn the graph how the web application is, which is said here the architecture. The architecture of a web application is drawn behind the actors. The first thing actually to that you as a user, as an end user, needs to access a web solution, a web application, a web, let's say, web resource or whatever, is the browser. Is the browser. An ASP.NET solution, an ASP.NET solution to be reached, you need the web browser. This is the first actor for sure. Either to reach it or to test it while implementing. The web server where the ASP.NET resides, resides. Application server, actually, this application server is another layer, it's another interface, it's another, let's say, access point that will help users to receive exactly what they need. It is dedicated to specify the application's requirements, sorry, not requirements, the required applications by the users, and direct them to the correct destinations from the both sides. Let's say a back-end also layer, which is a database server. In our example, we said last class that it is the SQL server. It's from Microsoft also. This is another layer where services, actually, where services are stored. So an ASP.NET to be dynamic, there have to be actually a background data. It has to be stored in somewhere. So to be stored, for our example, actually, we are taking the SQL server, which is a database server, to manage, let's say, our stored data in background. Those are actually main pillars to run the architecture of an ASP.NET solution. Yet, to make them rule and to make them actually run, we have some logic to gather them or to govern them. This logic here actually is the group of rules and policies to make the application run. You can open the EduWave, for example, from 8 to 4 only. This is a rule that the University of Frisbee has to implement. So this is a rule. So those are this is an example of a business logic. Any questions, please, so far? Any questions you have so far? Hanouf, any questions, Hanouf?
No, Step.
Okay, great. Keep going on. Still, we talk about the architecture where an ASP.NET solution is seen, or how it has to look like. We have to use actually the web browsers to display the front-end solutions. Means an application to be delivered to an end user, there have to be a web browser compatible with the front-end APIs. We have to have a medium in between the front end and the services. The services, they are residing in a web server or in a database server. So to reach from the front end to the service, we have to have a platform to communicate the front end with the service, and the vice versa, from the service to the web browser. Here, which is the WWW environment, the World Wide Web environment. Okay, this platform here will help us to communicate the front end to the service, to the back end, let's say, using a group of, let's say, technologies which are ruling the communication how to happen, which is in this example, the WWW. We are going to use the HTTP, the Hypertext Transfer Protocol, which is a group of rules to help us control the communication over the internet, over the WWW environment. Technologies built in the front-end solutions and even also the back-end solutions actually can be in question of those technologies. Actually, mainly we talk about an HTML-based solution. This is the very famous first actor to talk when design and architecture of an ASP.NET. ASP.NET. Actually, we defined just in a while that everything to be delivered over the www environment is a rendered HTML view. Means if it is not an HTML or extended HTML, it cannot be actually visualized in a web browser as a front end solution. I repeat, everything that if it is not rendered, we'll explain that in a while, as an HTML or something similar to the HTML, XHTML for example, it cannot be rendered and viewed and displayed on the web browser as a front end solution. Can you repeat what I said right now, please? Are you able to repeat the dilemma I said right now? I continue. Continue. The same actually architecture we saw just right now. It is seen. It is presented to us as a graph. Yet one terminology. It's a term, and it is actually a terminology that we have to memorize. Tier. Tier. We present just in a while. We present in a while that the group of actors designing the architecture of an ASP.NET solution. We said that the web browser is a layer. The web server is also a layer. The web application is also a layer. The database and the backend solution where to store data is also a layer. Layer, 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 layer. Instead of using the layer, we are going to use a technical word which describe a party responsible for doing a task from within the web application. Inside the web application, there is a party, an element, a member that is doing something inside the web application. Why you are late today? This party, let's continue. This party or this member, we are going to technically describe it or just call it as a tier. So the web browser is a tier, the first tier. Web server, where the application resides, is another second tier. Web application is a third tier. Logics, it's another tier. The database or where the store is another tier, and so on. So the tier is actually and let's say a position or a layer or an access point or a point where the application life cycle has to go through to pass through. Yeah, it's a member to make the service be delivered from the provider to whom is required. The client is requiring the service, and the server is having the service. So the server deliver the service through the tiers. Tier number one, number two, number three, number four, and so on. We can have n tiers. So in an application, in this example, you are having 5 tiers. But in general, we can have actually n tiers. Maybe 1 tier only, maybe 0 tier immediately from the server to the client, or sometimes we can have hundreds of tiers. It depends. It depends on the application itself. I give you the example, the Google Docs. To open those slides, the slides they are available in somewhere in Switzerland, for example, in the original company location. In there is the server where the service resides. So from there to us here, where those slides are displayed to us, there are tens of tiers. So they are not only 5; they are many and more, much more than this number. So the number of tiers is not fixed as per the example we are taking here. This is only an example. So we may have more. For example, in just one application, we may have for example, 10 application servers. Application server number one, application server number two, application server number three, and so on. So we may have actually more than this number of tiers. Another view of this architecture. So this is the service provider where the store resides. Actually, this is actually a more coherent diagram. The database server where the application resides, here it is, related immediately to the database server, actually, let's say host, where it is installed, and so on. So the group of logics that they control who is accessing, or who is having the right to access, or who is able to retrieve the data from the data store, the logics, the rules, and then after the application server to decide which service is exactly required from the service provider, from this service store, and then after a web server to help us deliver the www services. Then after actually our tools that we can utilize, the technologies that we can utilize to make the client view or visualize what the services are. So if we have so many services here, if the technologies they are not enhanced to work on the internet, they will not be delivered. The ASP.NET can run on the internet. JavaScript can run on the internet, and so on. There are so many technologies that we may refer to in order to deliver the service to the client over the internet. In our example, we are talking about the ASP.NET. And our example here, the main technology dominant, and this is the first unit topic, is the ASP.NET. Web docs, or sorry, Google Docs or Google Slides, they are not the unique example of web applications. So this is actually a Google Doc, this is actually a Google Slide, sorry, and this is an example of a web application solution. It's not unique. We cannot stand on this example only to deliver service. This is not the unique service that we can get over the WW environment. There are so many other things actually and services we can reach over the WWW environment. We will have the clear understanding of what is the WW and what is the internet and what is actually meant by web-based application. Just the time when the time comes. As per examples of web applications, actually an online system that helps us to make reservations, to reserve, to attend actually to a conference, to a seminar, to a workshop, to attend a classroom, to attend actually, to reserve for actually, to book an online, let's say, ticket for some activities or an auction. Yeah, you can do that. Other applications that they actually are a very famous example of web-based solutions. They are the gaming applications. You can play games online. So this is an example of a web application. Calendars. The Google Calendar is an example of Microsoft Calendar. Actually, it is. They are examples of web applications, and so on. So they are not the application. These Google Docs or the Google Slides. They are not the unique examples of web applications. Any questions, please? Here, any questions you have here, please?
No, teacher.
Okay, great. Still, actually, talking about the architecture only, but here actually we are presenting two different actually components or actors. Generally, we presented the application actually architecture earlier, defining the main actors, which are the web browser, web server, application, and database server. Then after we said that the logic is all in all. Here we are going to see it in different view. An architecture is a presentation of an interaction in between a hardware and a software. An architecture or based application. Here we are seeing it based on an interaction in between a hardware, let's say the laptop or the computer, desk computer, and a software, which is the web browser, something like that, or the tool you utilize to reach the solution. So the interaction between the hardware and the software designs, let's say, draws the web application diagram. Yet, besides of that, the software part here is segregated into those three elements, which is the actually the database engine or the data store schema, the logical rules that they are governing the use of, let's say, the data store, things like that, and the interactive logic in the sense of the application will run from 8 to 4 only. This is an example of an interaction rule. Any questions? Okay. So, as per what we saw so far, actually, we were able to define and clearly actually describe and prescribe what is a web application based on the ASP.NET technology. So, ASP.NET technology so far is the main actor for us in this book to utilize to design a dynamic web solution. And a web solution, actually, it is a web application, yes. And this web application, this designed dynamic web application, it is not something actually we have to recognize and that's it. We do one, two, three steps and we finished. No, there are issues and there are constraints that we have to consider in order to succeed in building those what we are expecting to have as a final designed web application. So there are challenges. There are challenges. Thus, there are challenges that we can trespass. Yes, this for sure, but we have to consider in order to succeed. Actually, I'd like to give you the chance to ask if you have any questions before I pass to the challenges. Actually, I'm giving you the chance here. I'm not going. Uh, I need to hear your feedback from the definition of the let's say the architecture or whatever the ASP.NET is for your view. So, any questions, please? Just a few seconds to interact. No questions. Okay. From the
No,
challenges,
Mr. Thank
great, great. So I believe that I've given you enough time so to interact. So from the challenges that we have to consider that developers or the web or the designed web application or web solution or web designed dynamic web application, they have to consider is the loosely coupled concept or context, the loosely coupled context or concept. Loosely coupled, actually, as per the word loosely, it is going to be actually lost, and it is in between two parties, a couple. So something to be lost from between two partners in this sense. The partners here in our view, they are the client, they are the client, the web browser, the client, and the service provider, the server. So those are the two parties. The client requests, the server provides. The server provides, the client displays. So those are the two parties. And loosely, something is going to be lost in between. This is the loosely coupled. Something is going to be lost in between both. This is the loosely coupled. And in sense here, actually, you are going to define a technology that the web is famous with, which is the fact that web designed web solutions, they are stateless. Or we can use technically, they are loosely coupled. They cause, or they are actually by nature, by default, they are loosely coupled. What does it mean? Here, actually, every request passed by the client, by the browser, actually, it has to be actually declared by the server that it is available or not. The client, the web server, will request the server to submit response. The server will declare yes, I do have or not. If yes, it will do. Otherwise, it will tell no, 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 no. It's not that I do not have the request response, so I don't have. But once the request is available, so there have to be actually a response sent from the web server to the web browser where the user is reading or displaying the results. Once this request has been terminated, the connection between the web server and the client is going to be disconnected. And here we see the loosely coupled, the loss. The loss is the disconnection here. Questions? What does it mean here? It means if the user is requiring to have this service again after 5 minutes or after 10 minutes or something like that, the resource has to be reloaded again. So, yes, the connection is going to be disconnected, yes, and lost, yes. Yet later on, actually the user can request again. The user can re-request again, whatever the service is. Loosely coupled. From the other challenges that the developers has to go with is that the front end solutions, they have to be actually deliver an easy to use interface, user friendly, a very user friendly interfaces, in the sense of users when they are actually accessing a resource, they have to have a good understanding of what is this resource and how it looks like and where the services are. So to register, they have to be actually find a register button very clearly viewed. To log in, they have to see the login button very clearly, and so on. So the interfaces, they are actually the user experience on top of the interfaces or the developed interfaces is one of the challenges that the developers has to consider. So those interfaces that would help actually users to navigate easy, to have actually an experience much more easier and let's say rich when compared to other service providers, means the user will be actually able to access the resources easily. He will not have to struggle accessing the resources. And this actually, because of this positive implementation that it represents a challenge to the developers, service provider will gain consumers, in the sense of consumers, they will not seek to go to other competitors if they are finding a very rich user interfaces with a totality of services. They will not go to other competitors. From the challenges also the context of the scalability. Actually, web servers, they are actually done to run on the web, and the clients over the web, over www environment, they are actually able to access the resource. But saying that, for example, the EduWave, and we are now actually in a period of add and drop, and still registration is going on. If you recognize very well, the EduWave is a little bit slow when we compare it to the normal days, not outside of the registration period. So nowadays they are a little bit slow. Why? Because all of us were using the resources at the same time. So the web application, the EduWave as an example, it is giving us the chance to all of us to access the resources available inside the EduWave without prior installation and without prior buying licenses. So immediately we just access the resource over the internet, and and this resource is going to be actually given access to all. This is an example of scalability. So as many as more users would come, the application has to adjust itself to give access to them all. Scalability. Actually, to ameliorate this behavior, there is a sort of an architecture via which we may draw the application and make it run much more better. The service-oriented architecture. So, the service-oriented architecture. This actually would be actually an enhancement to the service provider to help deliver much more qualitative services to end users. And those qualities, much more qualitative services to end users, they are a performance. They are indicating a performance of a web-based solution. So the web-based solution actually performs is generally tested and measured with how much actually it is successful deliver the services to end users whenever they are required without fail. Why? Because if the performance is weak, this is a problem. You have to have a continuous service without interruption. From the actually from the challenges also, we are going to developers actually have to recognize the best tools or technologies that they are actually able to be deliver the service to the majority of the clients. Means we can implement a solution using HTML only, a web-based solution. It might have some interaction with the users using HTML only, but can the HTML deliver all the services that the service provider is requiring? I don't think so. So the knowledge and the awareness of what are the best solutions we may refer to, like the ASP.NET in our example, is a must. This is a challenge because the developer has to recognize all the capabilities of the technologies available in the market to design the APIs, the front-end solutions, or the back-end solutions. From the other challenges also, not only the context of the implementation, but the security view, in the sense of an application or a dynamically designed web solution has to be actually secure enough to guarantee what it is actually delivering is trusted to the end users, and trusted by the end users is a perspective of the service provider. We have actually to recognize that there are solutions that they actually have to authenticate users, like the EduWave. You cannot see your transcript, you cannot register courses, you cannot submit your timetable over the EduWave if you do not authenticate yourself, username and password. This is a security feature. All of us, we can use the same username and password fields, but we will see different results inside. Me, if I use the username and password, I will see all of your profiles. You are my students. Otherwise, if you use the same username and password fields, you'll see only your profile and your marks and your own, let's say, material or materials. This is a security view that has to be considered while developing the application. This is another challenge also. It's not something easy to do. Any questions, please? Yes, I'll take the attendance now and stop the recording also.